we're going to dive into one of the most powerful ideas in mathematics, integration. Now, you've probably heard that integration is the opposite of differentiation. And that's true, but it's also much more. Imagine you're looking at a graph of a curve, let's say the speed of a car over time. If you want to know how far the car traveled during a certain period, what would you do? Well, if the speed were constant, you'd simply multiply speed by time. But if the speed is changing, if it's accelerating or slowing down, we can't just multiply. We have to account for all those little changes. That's where integration comes in. Integration is about accumulating small pieces to find a whole. Think of it like adding up infinitely many tiny slices of area under a curve. Each slice is so narrow that we can almost think of it as a rectangle, even though the curve bends and twists. When we add up all those infinitely small rectangles, using a concept called a limit, we find the total area. That's what the integral gives us. Now, symbolically, we write an integral using this fancy-looking elongated S shape. It stands for sum because we're summing up all those tiny contributions. If we have a function f of x, and we integrate it from a to b, we're asking, what is the total accumulation of f of x between x equals a and x equals b? In physics, integration helps us move from a rate to a total quantity, from velocity to distance, from force to work, from density to mass. Finally, there's a beautiful connection, called the fundamental theorem of calculus, that ties everything together. It says that if you first differentiate a function and then integrate it, or first integrate and then differentiate, you essentially return to where you started. Differentiation and integration are two sides of the same coin. So, in short, differentiation breaks things apart into rates of change, integration puts them back together into totals. Together, they form the heart of calculus, and they let us understand motion, growth, area, and much, much more.